Does anyone want to just don't care what they do for a living? They just want to make a lot of money. All right, Annie. That's recorded for posterity that Annie raised her hand. Does anybody know what an actuary is? So it's basically it's kind of the math of decision making. So in insurance, I mean, insurance people use who knows how many actuaries, but really any business needs to have at least some actuary that they call up and say, hey, I'm about to do this. Is this what's... Anyway, as far as jobs, you can get just a bachelor's degree, and there's not a lot of jobs you can just get a bachelor's degree and start making six figures right away. This is one of them. So it's like when I finished my PhD at Berkeley, like all the math people were graduating at the same time, and the undergraduates, they were all either going on to grad school, which I expected because this was Berkeley, and you'd think, okay, they're probably going on to grad school. Or the other half, I mean, about half of them were going to go all be actuaries. I didn't know what it was. So I was like, dude, what is this actuary everybody wants to do? Apparently, you can make a lot of money making monetary decisions for big companies. So, and one of the fundamental things that goes into that is Bayes' theorem or Bayes' rule, which, well, let me write down the answer right quick. Probability of A given B. I'm going to do the probability of B given A times probability of A over probability of A, probability of B given A, plus probability of A complement, probability of B given A complement. Or, sorry, we're not using C's for complements in this class. We're using bars. So A bar, B given A bar. Okay. What the hell is that talking about? Well, in real life, a lot of times, so basically what this is used to do is to switch the given part of a conditional probability. So a lot of times, well, this problem here, it says, you know the probability that someone is smokes cigars given that they're male, with the probability that they smoke cigars given that they're female. What if you turned around, somehow you knew this person smoked cigars, and you wanted to find the probability that they were male or female? Which that seems like a silly thing to do. But something more realistic, let's say, say you're a company, you know that you order goods from all sorts of different warehouses. Let me go back. Let me write down what I'm saying. So where this is used in real life, say you're a company, let's just make it easy, say 5% of what you get from warehouse A are bad, 2% of what you get from warehouse B are bad, and 7% of what you get from warehouse C are bad. And you get a shipment, and it turns out that it's bad. You want to know, hey, what's the probability that shipment came from A, or the probability that it came from B, or the probability it came from C? Right? If you want to say, okay, well, why would this matter? Well, there's a few things involved. Okay, maybe B gives you better stuff, but maybe it costs more to ship from B. Or maybe you can get so many bad shipments, but you really don't care. I mean, these things seem really silly, but when you actually put multi-million-dollar operations behind them, I mean, this can easily be tens or hundreds of thousands of dollars that come down to one decimal place difference. So this is what Bayes' theorem lets you do. It's like if you know the probabilities, so the probability of bad given A is 5%. What's the probability of A given that the shipment's bad? So when you want to turn it around, that's what Bayes' theorem does. All right? Okay, well, let's do this example, and I've used a lot more words than I really intended to there. So it says 51% of adults are males. So the probability of being male, period, is 0.51. So probability of being female is 0.49. 59% of males smoke cigars, 2.6% of females smoke cigars. So the probability of being a cigar smoker given that you're male is 0.096. The probability of being a cigar smoker given that you're female is 0.026. Right? And what are we looking for? We're looking for the probability So probability of being female for nothing else is 0.49. That's silly. So the probability of being female given they're a cigar smoker, well, again, go back to Bayes' theorem. Basically, you switch these around. So I want the probability of cigar smoker given female times probability of female. So probability of female, probability of cigar smoker given that you're female. And then the same thing again, probability female, probability you're a cigar smoker given female, plus the probability that you're not female times the probability that you're a cigar smoker given that you're not female. And all these numbers we know. So the probability that you're female, 0.49. What's the probability you're a cigar smoker given you're female? Yeah, 0.026. And then same thing on the bottom, 0.49, 0.026. Okay, in this particular problem, being not female, there's only two options. So if you're not female, then you are male. So the probability of being not female is 0.51. And probability that you're a cigar smoker given that you're not female, 0.096.
And how did you get that?
Oh, so again, I mean, being not female is the same as being male. So if you want the probability of being a cigar smoker if you're not female, that's the same as probability you're a cigar smoker and male, or given that you're male. And I was going to box that, but my pen quit working. There we go. So, yeah, just read that guy off. Okay. So, we've got equals, parentheses, 0.49 times 0.026 divided by, yeah, Catherine's putting her stuff up. Sadly, we're out of time. So we may do one more of these next time. I'd like to do one where there's three options instead of just two. 0.51 times 0.096. If I type that in right, it's 0.206. Cool. All right. So anyway, that's An example where you'd use that, I don't know, say if you're an insurance company and you're worried about people smoking. I mean, of course, now they actually added a deal where if you're a smoker, you have to declare that on your insurance. But used to, not all insurance required you to do that. You'd say, okay, well, let's put a little extra fee in there to cover the chance that they're smoking. Then you wouldn't have to charge them as much as you charge them. These odds are. Anyway, okay. Cool. Well, we'll do one or two more of those next time. I'll see y'all then.
Have a good day.
All right, you too, Jay.